Hi everyone, I am sitting down to record our last couple of mini lectures for this entire class, and of course the tablet that I had been so excited about using now refuses to charge. So I'm back on my normal computer, and so I apologize for that, but we are finishing up class, so I don't apologize for that part. All right, so what we're going to do is sort of quickly review the combination of folliculogenesis and oogenesis, and then move more into looking at how hormones are involved in controlling these processes. Now, in the last lecture, I spent a lot of time walking through the steps in this particular figure. I am not going to spend that time now. I just wanted to put it here as a reminder for what we're looking at. Essentially, what I'm going to do is show us some different images and give us a little bit more detail maybe about what's going on with folliculogenesis, and hopefully couple it to what's going on with oogenesis at the same time. So remember that these two processes are ongoing, and so when we're looking at this cell here, this egg, or what will become an egg, is this right here. So this blue half is looking at what's going on with the gamete, and then the green side is actually talking about what's happening with the cells that surround that gamete, which are our follicular cells or our granulosa cells. When we are talking about folliculogenesis, we are starting with primordial cells. So these are going to be the type of follicular cells that a female is born with. So at birth, we're going to have tons and tons of primordial follicles. So we're talking 1 to 2 million primordial follicles. Quite a while before ovulation actually occurs, about 12 follicles per ovary are going to begin sort of this pathway to maturation. So there are 12. So if we look, let me take a step back. If we look at a cross section of an ovary, what we see sort of along this edge here, all these little blue dots, those are going to be the primordial follicles. So they're just hanging out, they're not doing anything, they're sort of waiting their turn. We can also see that we have some of these larger cells sort of scattered throughout. Those are going to be these primary, secondary, tertiary oocytes that are sort of staged for ovulation. Okay, and so by the time we are sort of down in this area, we see these really big follicles. These are the follicles that have survived and are likely to be ovulated in the next cycle. So we do have within an ovary follicles and oocytes that are at multiple stages of development, so that we every month are ready for ovulation to occur. Okay, so at birth, we're going to have 1 to 2 million of these primordial follicles. That's going to be an oocyte. That oocyte is a primary oocyte at this point. It has paused at this stage until we sort of recruit it to begin the maturation process. The actual follicular cells are just a single layer of squamous follicular cells surrounding that oocyte. So after we've recruited those 24-ish primordial follicles to begin the pathway to maturation, that starts almost 300 days before ovulation. 140 days before ovulation, 140 days into this process, we are now going to be at the point of primary follicles. So the oocyte has gotten larger, and we begin to see changes in the follicular cells. They go from squamous to cuboidal. So we can see here that they have changed. They're getting a little bit sort of plumper, and they're really getting ready to go through mitosis and create multiple layers of follicular cells. So we've also increased the size. Remember, these primordial follicles are these little tiny dots along the edge of the cortex. Here again, shown in blue, we have the primary follicles, so they are getting larger. As we move closer and closer to the point of ovulation, we're 170 days into the cycle now, we are going to become secondary follicles. And again, you can see, highlighted in blue here, much, much larger at this point. So the oocytes have gotten larger. They are going through those steps of meiosis. The follicular cells have increased the number of layers. They've gone from a simple squamous, we're now in 2 or more layers. So you can see here we have at least 2 layers of these cells sort of stacked on top of each other. And then over here we can see again we're building multiple layers as we move inward. We now include a zona pellucida as well as our theca folliculi. So the zona pellucida, we can see sort of surrounding this egg here, is around the oocyte. The theca folliculi actually encloses the entire follicle. So all the way around this outside edge, we have these theca cells, and they are connective tissue. They're really there to help sort of protect what's going on in this follicle. Moving even closer to ovulation, so now we're about 60 days before ovulation, so this would be 2 menstrual cycles. We're going to see a couple of the recruited cells become tertiary follicles. So in the tertiary follicles, we see our follicular cells are going to start secreting fluid or liquid sort of into the middle of the structure. So we have this sort of open space here. This is the oocyte. These are follicular cells sort of in this mound. And then this is going to be this pool of liquid. So that pool of liquid is called the antrum. And so essentially this antrum is starting to begin the separation process between the follicular cells and the oocyte. So the oocyte will have what's called the cumulus oophorus around it. That is just this mound of follicular cells that sort of cover the oocyte and keep it attached to the follicular cells. But we do see that we begin to separate the structure out, so that eventually just this oocyte as well as that cumulus oophorus can be ovulated. All right, so about 1 cycle before ovulation, we have one follicle that becomes dominant. There's really no way to determine which follicle is going to become dominant, but of those 12 within an ovary that we started with, at this point, usually 1 remains. We're only going to ovulate 1 of those follicles. So 1 follicle becomes dominant. It basically starts to sequester all of the FSH, that follicle stimulating hormone that's coming down from the anterior pituitary, and it is getting ready to be ovulated. So again, we still have these structures, so we still have the cumula oophorus and we still have the corona radiata. It's probably a little bit easier to see here. So we have, this is going to be the cumulus oophorus, these follicular cells, and then the zona pellucida is in here. So the zona pellucida forms this nice protective barrier right around that egg. And then this mound of follicular cells, that's the cumulus oophorus. Okay, so that sort of late stage mature follicle there that we just saw is what's going to end up being ovulated. So I think now we can start putting together the pieces of what's going on with folliculogenesis and what's going on with our hormones and sort of how these things are related. So what we're going to start looking at is called the sexual cycle. The sexual cycle is essentially talking about the rhythm of the ovaries and the uterus. So how do the ovaries and the uterus work together to have follicles and eggs maturing, to go through ovulation, and then that's all happening in the ovary. Meanwhile, while all that's happening, we are preparing the uterus for implantation should a fertilization event occur. The sexual cycle does differ from female to female. The average or sort of the standard number that we use is every 28 days. This cycle repeats. That does vary, and it can vary pretty substantially. What's considered, I'm going to say quote unquote normal would be 20 to 45 days. What's really most important is if it's regular within a female. So if a female has a 48-day cycle, if it's always 48 days, that's usually okay. So we have, when we're looking at this right here, we have 2 weeks of what's called the follicular phase, followed by 2 weeks of what's called the luteal phase. During the follicular phase, we're actually going to start with menstruation, that indicates the follicular phase is beginning. So that's obviously coming from the uterus and not the ovaries. Ovulation happens around day 14. So day 1 is the first day of the menstrual cycle. Day 14 is when we would expect ovulation to occur. The next 2 weeks are sort of marked by preparation of the uterus for implantation. And then should implantation not occur, the cycle restarts at day 1. So we start back with that menstrual cycle. We do have a hierarchy of hormonal control. We have the hypothalamus, which directs the anterior pituitary. The anterior pituitary is going to secrete hormones that acts on the ovaries, which is what we're looking at on this slide. And then the ovaries are going to secrete hormones that act primarily on the uterus. And that's what we'll look at in a few minutes here. So the ovaries have feedback control over both the hypothalamus and the pituitary, and ultimately the ovaries also determine what's going on in the uterus. So the ovaries and the events happening in the ovaries are hugely important in determining the sexual cycle and ovulation, implantation, and preparation for pregnancy. All right, so let's sort of walk through what we have going on in this particular part of the sexual cycle. So all we're looking at here are the hormones that are coming from the anterior pituitary and their what they're doing to the ovaries. So what's going on in the ovaries as a result of these hormones. So in this top box of this figure, we are looking at 2 hormones. We have FSH shown here in blue, right? And then we have LH shown here in red. These are showing sort of general concentrations at different times over this 28-day cycle. This bottom box has what's going on in the ovaries. So we start with our primary, secondary, tertiary, and then ovulation, followed by the corpus luteum, involution, corpus albicans, and then the sort of preparation of our new primordial follicles. On the bottom, we have our days, so 1 through 28, and then whether we're in the follicular phase or the luteal phase. So the follicular phase is driven by what's happening in the ovaries and these follicular cells, because they are going to be in large part secreting hormones. Luteal phase has to do with the moon. I don't ask me why we named this the luteal phase, but luteal basically means moon, so something about women and cycles and the moon. But this is going to be where we have ovulated, so that egg has been released from the ovaries and is now in a uterine tube or heading towards the uterus, and prepping the body for either implantation or to begin the cycle again. All right, so our follicular phase is going to be usually from days 1 to about day 14. So that would be marked by day 1 would be the beginning of menstrual cycle, so beginning of actual menstrual bleeding. Day 14 is marked by ovulation. This phase is incredibly variable and incredibly difficult to predict when ovulation actually occurs. We say that the luteal phase is 14 days. Again, that's an average. Some women may have an 18-day luteal phase, which may mean that they actually ovulate on day 10. Some women may have a 10-day luteal phase, which would mean that they ovulate on day 18. This is very, very variable, and it can be hard to sort of pinpoint and predict, which is why contraceptive methods like counting days aren't necessarily always dead on. And actually, even within a woman, ovulation can change, maybe from day 12 one month to day 15 the next month. And so it becomes very hard to predict which days would be fertile days and which days would not. So, all right, so let's sort of look here at our hormone profile. We have FSH coming from the anterior pituitary. At the beginning of our follicular phase, that concentration is pretty high. So we get sort of this peak of FSH that is going to drive the follicles. Remember these, this like tertiary follicle is going to start sequestering all of the FSH it can get, and it drives it to the point of maturity so that we can get to ovulation. So the follicular cells are responding to the FSH, and the FSH is saying, all right, start developing, let's go. We got to get our next set recruited. We got to push our secondaries to tertiaries, our tertiaries to ovulatory, you know, all these sorts of sort of steps in there. In response, and we'll see this on the other half of this graph in a little bit, the follicles or the follicular cells are going to secrete estrogens, which are going to act on the rest of the body. So right before ovulation, we're going to see that our dominant follicle, so that one that's actually going to be ovulated, becomes really sensitive to our hormones, so FSH, LH, as well as estrogen, and that is going to push that dominant follicle to the point of ovulation. Okay, so I'm going to leave you with a cliffhanger there and come back with our next mini lecture in just a minute.